All right, so let's start with concept A, which is I can model systems of equations and systems of inequalities. So it says Bobby pays $75 plus $10 for each day he parks in the garage. So right away I can tell that this is a equation written in slope-intercept form because we have a starting amount plus basically an amount that's being added per day. So I'm going to write that in slope-intercept form. So that's going to be y equals 10x plus 75. And the next equation says Lily pays $120 plus $5 for each day she parks in her garage. So again, that's written in slope-intercept form. So that's $5 per day plus the initial $120. It says write a system of linear equations to represent your solution or situation. Identify your variables. So for this particular problem, x represents the number of days, and y represents the total cost. Now it says solve using a method of your choice. Well, since these are both written in slope-intercept form, you could graph. However, since I see that these numbers are so big, I'm not going to graph. I'm going to solve by using substitution. All right, so to solve by using substitution, we're going to set the two equations equal to each other. So 10x plus 75 equals 5x plus 120. And now we're going to solve. So I'm going to subtract 5x. So 5x plus 75 equals 120. And then I'm going to subtract 75 from both sides. So I have 5x equals 120 minus 75 is 45. And divide by 5. So x equals 9. Now I'm going to solve for y by plugging this back in. So now that I have x equals 9, I'm going to plug it back into either equation. Well, I'm going to plug it back into the second one just because the numbers are a little bit smaller here. So it's going to be y equals 5 times 9 plus 120. So that's going to be 45 plus 120. So y is going to be equal 165. So my solution is going to be 9, 165. So that means they're going to cost the same after 9 days. Both will cost $165 after 9 days. All right, so now let's take a look at the second one. It says Felix is selling balloons for $2 each and party hats for $2.25. So since I see two different quantities, I know this is going to be written in standard form. So it's going to be $2. X is going to represent party hats or balloons, and $2.25 is going to represent party hats. So that's going to be Y. And it says he made a total of $92. And then it says the total number of balloons and party hats sold was 44. So that's going to be a second equation representing just the total amount shown. So that's going to be x plus y is equal to 44. So let's identify what our variables are. So x in this case is going to be the number of balloons, and y represents the number of party hats. All right, so then it does say that we need to solve. So in this case, since both equations are written in standard form, I'm going to use elimination. You could also use substitution. However, if you're going to use substitution, you're going to have to solve for either x or y in this equation. So I'm going to solve using elimination, but in order to eliminate, I'm going to have to multiply one of the equations. So it doesn't matter. It's going to be the same amount to either eliminate x or y, but I think multiplying by 2 is easier than multiplying by 225. All right, so I'm going to rewrite my system here, the first one, since I'm not multiplying this one. And I'm going to multiply the whole second equation by 2. So the whole second equation becomes 2x plus 2. And the only reason I'm writing like $2 is just so it matches the first one. And then 44 times 2 is going to be 88. All right, so since my equations are, now we have the same number, we're going to eliminate x. However, since they're the same sign, we know that we're going to have to subtract the two equations. All right, so 2x x minus 2x, that's 0. 225 minus $2 is going to be 0.25y. And then 92 minus 88 is equal to 4. Then we're going to divide both sides by 0.25. So 4 divided by 0.25 gives us 16. Now that we have that, we're going to take that and plug it into either equation. So I'm actually going to plug it into the second equation because that seems easier. So for the second equation, it's going to be x plus 16 is equal to 44. And then just subtract 16 to get x. So 44 minus 16 gives me 28. So that means we sold 28 balloons and 16 party hats. All right, so now let's look at the last case. So it says a small tech company makes $600 per cell phone sold and $300 per tablet sold. So again, I see two different quantities, so I'm going to write two different, or it's going to be in standard form. So it's going to be 600x plus 300y. It says a company can make no more than 100 devices total per month due to the number of employees it has. So that's going to be another equation. That equation is going to represent the number of devices that they're making. So that means x plus y, and it says no more than, which means that has to be less than or equal to 100. It says the company wants to make at least $50,000 a month. So at least we're going to use a greater than or equal to symbol, and that's going to be 50,000. So here's our system of linear inequalities, and let's identify our variables. So we aren't going to need to solve this one. So x is going to be the number of cell phones, and y is going to be the number of tablets. All right, so now let's move on to concept B. So concept B is I can solve systems of equations. So the first one says solve and show all work. So I see that this one is written in two different forms. The second form is slope-intercept form, and that means our variables by itself, which means I can take this and plug it in here. So I'm going to use substitution. So when I plug it in, it's going to be, the first equation is negative 5x plus 6, but now I'm going to plug in the 6x plus 14 is equal to 22. So from here, we're going to go ahead and distribute. So it's going to be negative 5x plus 36x, because 6 times 6x is 36x, and then 6 times 14 is 84, is equal to 22. Now we're going to combine like terms, so I can combine my x terms. So that's 31x plus 84 is equal to 22. Subtract 84 from both sides. So then I have 31x equals 22 minus 84 is negative 62. And then divide by 31. So we have x equals negative 2. So now that we have that, we're going to take that and plug it into either equation. So I'm going to plug it into the second equation. So it's going to be y equals 6 times negative 2 plus 14. So that's going to be negative 12 plus 14. So y is equal to positive 2. Okay, so part B says, which method did you choose to solve the system of equations? Explain your choice. So I use the substitution method. And I chose that because one of my variables, or one of my equations, was solved for x, or solved for y. So you could easily substitute it in. Okay. Let's look at the second problem. So it says solve the system, show all work. So I'm looking at this and I see that they're both written in standard form, which means I'm going to use elimination. So as it stands, we can't easily eliminate. So we have to ask, is it easier to turn a 2 into a 6 or a 2 into a 3? And it's easier to turn a 2 into a 6, and we can do that by multiplying the top equation by 3. So I'm just going to write that underneath here. So 3 times 2x is 6x. 3 times negative 2y is going to be negative 6y. And then 3 times 6 is going to be 18. And now now I know I'm going to eliminate my x variable. And since the equations are the same, I'm going to add. So negative 6x plus 6x is 0. Negative 3y plus negative 6y is going to be negative 9y. And then negative 9 plus 18 is going to be positive 9. To finish solving, we're going to divide both by negative 9. So y is going to be equal to negative 1. So now that we have that, I'm going to plug it back in to one of my equations. It looks like maybe the first one might be easier, so I'm going to plug it back into the first equation. So I have 2x minus 2 times negative 1 is equal to 6. So 2x, negative 2 times negative 1 is positive 2. Subtract 2. So I have 2x is equal to 4, and then divide by 2. So x is equal to 2. So my solution is 2, negative 1. So which method did I use? I used elimination. And I chose elimination because both equations were in standard form. All right, so now let's look at concept C. I can describe and determine the number of solutions for a given system of equations. Identify if they have no solution, one solution, or infinite solutions. So for the first equation, remember the solution when graphing is when the lines intersect. Well, these lines are parallel, so that means they're going to have no solution. And the reason I know is because the lines are parallel. So they won't intersect. All right, the second equation, I see that they're intersecting at one point, which means that they're going to have one solution. And the reason I know is because they intersect at one point. All right, number 3, this one we don't have a graph, so we have to look at the equations. And remember, when determining if lines are going to intersect or not, we have to look at the slope and the y-intercept. So in this case, if the slopes are different, they're going to intersect once. So that means it's going to be one solution. And our reason is they'll intersect once because the slopes are different. Okay, the next one, we look at the slopes. The slopes are the same, which means that they can either be parallel or identical. But then when we look at the y-intercept, since the y-intercepts are the same, that means that the lines are identical, which means that they're going to be two lines right on top of each other, which means that there's going to be infinite solutions. And I'm going to say the lines are identical. All right, the last situation here, so we have to be a little bit careful because if we look, we might at first say, oh, well, the slopes are different because this is 3 and negative 3, but if you notice, this isn't in slope-intercept form. So you have to add 3x. So then the second equation becomes y equals 3x plus 37. So now when comparing our slopes, this slope is 3x, this slope is 3x, and we compare our y-intercepts, 14 and 37, that means the lines are going to be parallel, which means that there's going to be no solution. And I'm going to say lines are parallel because slopes are the same, y-intercepts are different, so they won't intersect. All right, so finally, the last concept, I can graph and solve a system of equations and a system of inequalities. So the first one is graphing a system of equations, and we're going to determine the solution. So we're going to look and see where the points cross. So graphing the first line, my first point is at 5, and my slope is negative 2, or negative 2 over 1. So I'm going to go down 2 over 1, and I'm going to continue this pattern. And I'm going to go ahead and draw my line. Okay, now I'm going to graph my second line. My y-intercept is at -7, and my slope is +2. So 2 over 1, up 2 over 1, up 2 over 1. And I'm going to go ahead and connect that line. So now I'm looking for my point of intersection, and I can clearly see it's right there, and the coordinate to that point is going to be 3, -1. All right, now we're graphing a system of linear inequalities. So we're going to graph like normal. So the first line starts at -3. My slope is -1/4. So down 1 over 4, down 1 over 4, up and to the left, up and to the left. For this one, my line is going to be dashed since there's no line underneath my inequality. And now we're going to decide which side to shade. So we're going to plug in the point 0, 0. So 0 is greater than -1/4 times 0 is just 0 minus 3. So that 0 is greater than -3. That's a true statement. So here's my test point, which means that I'm going to go ahead and shade everything above the line. Okay. Now I'm going to graph my second line in blue. So I start at -5, and my slope is 4/3. So up 4 over 3, up 4 over 3, up 4 over 3, down and to the left. This line is going to be solid since it is a less than or equal to symbol. And now I'm going to go ahead and test my point. So I'm going to plug in 0, 0. So 0 is less than or equal to 0 minus 5. So 0 is less than or equal to -5. That is false. All right, since that's false, my test point was right here, which means I'm going to shade the other side of my line. So that means I'm going to shade, oops, let me use the correct color. That means I'm going to shade below the line here. So I'm just going to darken in purple where my solution zone is for these inequalities, and it's going to be where it's overlapping. So it's going to be this area here. So then it says plot and label one solution on the graph, use algebra to check your answer. So I'm going to say maybe the point right here. So we'll say 4, -3. And we're going to plug it in to make sure that that is a solution. So for the first, let me actually erase what I wrote up here. Oops, why can't I erase that? For some reason, I can't erase that. Okay, so I'm going to plug in 4, -3. So it's going to be -3 is greater than -1 over 4 times 4 minus 3. So I'm going to put the left hand or the right hand side of my calculator. So -1 over 4 times 4 minus 3 gives me -4. So -3 is greater than -4. That's true. And now I'm going to plug it into the second equation. So it's going to be -3 is less than or equal to 4 over 3 times 4 minus 5. So again, I'm going to put the second part in my calculator, 4 over 3 times 4 minus 5. So that's going to be -3 is less than or equal to 0.3 repeating, and that's also true. So that shows that that is a solution, since it made both inequalities true.